Hello everyone, my name is Jafar and I will be giving a presentation on the Euler's method. As you may be wondering, what is the Euler's method? On the screen now is a definition, but essentially the Euler's method is a technique to find the approximate solution curve using a series of short line segments. Here is an example of the Euler's method to get everyone familiar with it. For this example, we will let dy dx equals to x plus y. When x equals to 0, y will equal to 1. When trying to solve for y, we will get y equals to 2e power x minus 1. I made a table to better visualize the data. As we see here, I have three different variables, x, y, and the next value of y. I used step size, as we see here, equals to 1. This means that the x value will increase by 1 for each step. For the y value, we see that when x equals to 0, y will equal to 1. So I will put 1 here. To calculate the next value of y, I need to use the formula current value of y plus the step size times function xy, which equals to the gradient. Using this formula, we can see that the next value of y will be 2. I then repeat this step 3 more times. As we see here, I plotted out the points to compare it with the graph of equation y equals to 2e power x minus 1. And as expected, the method helped us find the approximate answer of the graph. I will now use an Excel sheet to solve the IVP. This is the formula we will be using as the example before. In the IVP, we are given dy dx equals to x squared plus 1 over y, and when x equals to 0, y equals to 1. And we need to find the approximate value of y when x equals to 1. I will be using these columns similar to the example before. I will use step size equals to 1. The formula I will use for x is the previous value of x plus the step size. The formula for y will be the Euler's method. And lastly, the function xy equals to the gradient. We now know that when the step size equals to 1, the approximate value of y is 2. After doing my own calculations, I can find that the y value equals to 1.915. We can find the approximate error by taking 1.915 minus the approximate value from the Euler's method, which will give us negative 0.085. What if we change the step size from 1 to 0.1? As we can see, as we change the step size, the x value will change from 1 to 0.1. But we can easily find when x equals to 1 by simply dragging this part down. We can now see the new approximate value of y is now much closer to the actual value. Now we should find the new approximate error. As we see, the new approximate error is much closer to 0. This means that the smaller the step size, the lesser the margin of error. That's the end of my video. Thank you for watching.